Hi, today we're looking at Functional Skills Entry Level 1 Maths. This is the Pearson Edexcel exam board. We've got the Set 1 papers and we're going to start with the non-calculator section. Question 1. Jane works in a daycare centre. She looks after 13 children. There are 5 boys. The rest of the children are girls. Jane says there are 7 girls. Is Jane correct? Show why you think this. Right, well what we can do is we can work out how many girls we think there should be and then see if we agree with Jane. Well, if Jane's looking after 13 children altogether and 5 are boys, then the rest of them must be girls. So what we want is we want a 13 and we want to subtract or take away the number of boys. So if we count back from 13, so start with 13 and we're going to count back. So 12, 11, 10, 9, 8. So we're left with 8. Well, 8 is not equal to 7. So is Jane correct? No, she's not. She thinks there's 7 girls. There's actually 8. So what we need to do is tick no down here. Question 2. Jane gives stars to children as a reward. Andy has 12 stars. Jane gives Andy another 7 stars. How many stars does Andy have now? Okay, so with this one, we need to count on now because we want 7 more stars. So what we want is we want our 12 plus an extra 7. So then we start with 12 and we count on 13, 14, 15, 16, 17, 18, 19. That's our 7 added on to give us 19. And we can underline it to show that's our answer. Question 3. Jane works out the number of stars for Mo. What is 9 add 8? So we can show that as 9 plus 8, but means the same thing. Plus, add this symbol. So we're just going to count on again, but starting from 9. So 10, 11, 12, 13, 14, 15, 16, 17. And again, if we want to, we can underline that one. So now we're on to the calculator section. Jane works in a daycare centre. There are 4 groups of children. A chart shows the number of children in each group. So let's move this up and see the chart here. Okay. How many more children are there in group D than group A? Okay, so we want the difference between group D and A. Well, A is already here. Okay, so A is at 6 children. Group D is up here, so let's read across. So we need to get up to here. Well, if we're already at 6, how many more to get up here? Well, in fact, it doesn't matter that it's 6. We can just say, well, this is 1, 2, 3, 4. So we're adding on 4. So the answer simply is 4. If you wanted, you could take 10, and subtract 6, but actually it's much easier to just count on from the smaller number until we get up to the big one. Question 2. Jane chooses a bucket filled with building blocks. Bucket A has 9 blocks, bucket B has 11 blocks, bucket C has 12 blocks, and bucket D has 6 blocks. She chooses the bucket that has the most blocks. Which bucket does Jane choose? Well, we can compare the numbers, but let's just compare 2 at a time. So 9 and 11, which one's bigger? Well, this has got 2 digits, so it's going to be bigger than a 1-digit number. Okay, so we can rule out that one. Okay, we've got 11 blocks here. 12, well, 12 is 1 more than 11. So, again, we can cross out that one now, because we know 12 is bigger than 11. And 6, well, this is going back to a 1-digit number. So this is the one we want. But it actually says, which bucket does Jane choose? So it's not the number we need the number to find the answer, but the actual bucket we're looking at is bucket C. So we can go down and tick that one there. Question 3. This is the shape of a building block. What is the name of this shape? Well, I know this is a 3-dimensional shape because it's got width, depth and height. Now, let's have a look at the options we've got. Well, we've got a rectangle, we've got a circle, we've got a cube and we've got a triangle. Well, I know a cube is the only shape of these which is 3-dimensional. So it must be that one. And then we can have another look at it. There's our cube. Looks like a dice. And if we want, just so that we remind ourselves, a rectangle, well, a rectangle would look something like that. A circle. There's our circle. A cube, well, we've got it up there. And a triangle. It's going to have 3 sides, something like that. Question 4. Jane chooses a toy car with the smallest height. Which toy car does Jane choose? So if it's the smallest height, this means we want the smallest number. And we've got 4 to choose from here. So again, we're comparing the numbers, but it's nicer to just compare 2 at a time, I think. So we've got 12 and we've got 10. Well, 10, 11, 12. 12 is bigger than 10. So, oh, actually, we want the smallest. Sorry, forget that. So it could be 10. Okay, put a question mark for now. But it's definitely not 12, because 12 is bigger than 10. What about 20? Well, 20 is bigger than 10, so it can't be 20. And what about 15? Well, if we count on, and we know 20 is bigger than 10 because we've got more 10s here. We've got 1 10 here, we've got 2 10s here. 10 and 15. Well, if we count from 10, we'd get 11, 12, 13, 14, 15. So 15 is bigger. So although I started to cross it out, the actual one we want is toy car B. Well, that shows why it's important to read the question carefully, because sometimes I'll want the bigger number, sometimes I'll want the smaller one. Question 5. Jane takes a group of children to the playground. The diagram shows part of the playground. So we've got a swing and we've got a slide. And the question is, where is the slide in the diagram? And we've got 4 options here. It's either to the left of the swing, to the right of the swing, behind the swing, or under the swing. Well, they're next to each other, so it's definitely not behind the swing, and it's not under the swing. So these are the keywords we're looking at. So we want either, is it to the left of the swing or to the right? Well, the left would be over here, and it's not to the left, so it must be the right of the swing. Question 6. Jane has these playmats and footballs. How many footballs does Jane have? We've got 1, 2, 3, 4, 5, 6, 7. So it's good to either write the number with them or cross them off as you count, so you don't double count or miss any out. And they haven't asked about the playmats at all, so we can actually ignore all of these. And we've just got our 7 footballs. Okay, question 7. The clock shows the time Jane goes to lunch. What is the time on the clock? Well, we look at the smaller hand, which is the hour hand, and that's pointing directly to the 1. And the minute hand is on the 12, so it must be an o'clock, pointing to the 1, so it must be 1 o'clock. And if we look down at the answer section, they've already written the o'clock in, so we can just put the number 1. You could write the word 1 if you want as well. That would be fine. Question 8. Jane chooses a meal from a menu. And we've got pizza for £8, fish for £14, salad for £6, chicken for £9, lamb for £15, and burger for £11. She has £7 to spend on a meal. Which meal will Jane choose? So we want a meal that's £7 or less. So pizza's £8. 8's bigger than 7, so it's not going to be the pizza. The fish, well, this is a 2-digit number, so we know it must be bigger than a single-digit number, so it's not the fish. Salad, well, 6, 7, so 6 is less than 7. So this could be the answer, but let's check the others to make sure. 9, well, 7, 8, 9, so 9's more than 7, so it's not the chicken. This is a 2-digit number, so it can't be that one. And this is a 2-digit number again, so it can't be this one because it's bigger than the £7, the single-digit number we've got there. So it must be our salad. Question 9. Jane pays for her meal and drink. She gives this money at the till. How much money does Jane give in total? And it does say use the correct symbol for money. Okay, but if we focus on how much money does she give? Well, let's start with the bigger value, the biggest values first. So we've got a note here, so we've got a £5 note. So we've got 5. So we can cross this one off because we've used it. Then we've got a £2. We've got another £2. Then we've got a £1. And we've got another £1. So we want to know what the total of this is. So we can count. Let's start with the 5, the biggest number, and we'll count on. So we count on 2, we get 6, 7. Count on another 2, 8, 9. Count on 1, takes up to 10. And one more, that'll take us up to 11. Now remember they said use the correct symbol for money. So we draw our pound sign and then put our 11. Doesn't matter if your pound sign isn't brilliant. We've got one to copy, so try to get as close to that as you can. Question 10. There are 18 toy cars on a shelf. 3 cars are blue. The other cars on the shelf are red. This is how Jane works out how many toy cars are red. So she takes the total. She takes away the 3 blue ones, and that tells us how many are left. So we've got 18 minus 3 equals 15. Jane can check her answer in a different way. Show how Jane can check her answer. Well, they say check her answer, so her answer is actually 15. So we want to start with the 15. Well, if we know 3 of them are blue, what we can check is, well, if we add the blue ones back on, do we get to the 18 that we started with? So if we do the 15 and add on the 3, so we've got 15, 16, 17, 18. That does get us back where we started, so that looks fine. And remember, with this paper, you can use a calculator as well. So we could also check this with our calculator. We'd just type 15 plus 3 equals 18. Yeah, that looks good there. Question 11. Jane adds 6 and 11 and gets 17. How can Jane show that 6 add 11 is 17? Okay. Well, actually, we just used our calculator for the previous question. I'm going to use it again to test these ones out. So the bit we're going to type in the calculator is going to be the calculation part here. So if we do our 6 minus 11, we get 5. Well, actually, we get minus 5, but it's definitely not 17. So it's not that one. This one here, we've got 11 minus 6 for the calculation. So we clear the calculator. 11 minus 6. 5, definitely not 17, so it can't be that one. Let's try over here. Clear our calculator again. We've got 6 plus 11. Ah, that does give us 17. So it looks like this could be our answer, but let's check the last one as well. Again, it's the calculation bit that we're interested in. So the 11 plus 17, 28. So it's not that one. So that's the one we thought looked good. Question 12. Jane makes a tally chart of toys. Okay, so we've got for train, we've got 1 mark for each of the trains that they've got. For cars, we've got these. So the way that we would count these, if for trains, we've got 1, 2, 3, 4 trains. For cars, we've got 1, 2, 3, 4. And then for the 5th, we put a stripe through it. So that would be 5, and then 6, 7, 8, and so on. How many more games than dolls are there? So we're only interested in games and dolls. So that's games and dolls. So we're not interested in trains. We're not interested in cars. So we can forget about them. And how many more games? So we can count. We can do it 2 ways, actually. What I'm going to do first of all is say, well, let's see how many games we've got. Remember, each of these, when they've got a line through it, it means it's 5. So that's 5 plus another group of 5, and then 2. Okay, so 5 plus 5. Well, if we use our calculator, 5 plus 5 plus 2 gives us 12. And for dolls, we've got a set of 5 here. We know it's 5 because it's got the line through it. And then we've got 1, 2, 3, 4. So again, we can use our calculator. 5 plus 4, or we could count on, so 5 plus 4 gives us 9. If we want to know how many more games than dolls, we actually need to take the 9 away from the 12. So 12 minus or take away 9 gives us 3. Now the other way I was talking about is we can say, well, if we've already got 9 dolls, we want to know how many more games there are. Well, so 9 would be this 5 and 1, 2, 3, 4. So the extra games that we've got would be 1, 2, 3. Which is the same as the answer we worked out before. Jane has these crayons. How many crayons does Jane have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And as you saw, I cross them off to make sure I don't miss any or double count any. In fact, what can be good, once I've got to the end of the row here, maybe I could write 7. And then I can see, this looks like the same. So I could then use my calculator and say, well, I've got 7 on the top row, and another 7, and another 7, which gives me 14. But I think counting is a nice way to do it. Question 14. Jane takes a holiday in summer. She goes back to work the next season after summer. What is the name of the season when Jane goes back to work? So we're testing all of our seasons here. So we've got summer at the moment. The season after summer is autumn. And to help, if we think the season before summer is spring, and before spring we have winter. But then, of course, after autumn we have winter as well. And then it just continues in a cycle. But after summer we have autumn. So we can write that in there. Okay, so I hope you found this video helpful. Please like the video, subscribe to the channel, and look forward to seeing you again soon. Thank you.